The development of the atomic model is a fascinating journey that began in the 5th century BC with the ideas of Democritus and has evolved into the sophisticated and complex understanding we have today. Democritus, an ancient Greek philosopher, was one of the first to propose that matter is composed of small, indivisible particles, which he called atomos, meaning uncuttable. His ideas were purely philosophical, as there was no experimental evidence to support them. Nevertheless, Democritus's concept of the atom laid the groundwork for future scientific inquiry. Fast forward to the early 19th century, when English chemist John Dalton revived the idea of atoms, but with a scientific basis. Dalton proposed that all matter is made of atoms, which are indivisible and indestructible particles. He suggested that each element consists of identical atoms unique to that element and that chemical reactions involve the rearrangement of these atoms. Dalton's atomic theory provided a clear explanation for the laws of chemical combination, including the law of definite proportions and the law of multiple proportions, and marked the beginning of modern atomic theory. In 1897, the atomic model underwent a significant change with the discovery of the electron by J.J. Thomson. Using a cathode ray tube, Thomson demonstrated that atoms contain tiny negatively charged particles, which he called electrons. This discovery challenged Dalton's idea of the atom as an indivisible particle. Thomson proposed the plum pudding model of the atom, in which the atom was thought to be a sphere of positive charge with negatively charged electrons embedded within it, like plums in a pudding. Although this model was groundbreaking, it was soon replaced by a more accurate representation of atomic structure. In 1911, Ernest Rutherford, a physicist from New Zealand, conducted a series of experiments that led to the rejection of the plum pudding model. Rutherford's famous gold foil experiment involved firing alpha particles at a thin sheet of gold foil. He observed that most of the alpha particles passed through the foil, but a small fraction were deflected at large angles, and some even bounced back. This unexpected result led Rutherford to propose a new model of the atom, known as the nuclear model. He suggested that the atom consists of a small, dense, positively charged nucleus at its center, with electrons orbiting around this nucleus, similar to planets orbiting the Sun. This nuclear model revealed that most of the atom is empty space, with the nucleus containing most of the atom's mass. As the understanding of the atom continued to evolve, further discoveries refined Rutherford's nuclear model. In 1932, James Chadwick, a British physicist, discovered the neutron, a neutral particle within the nucleus. Chadwick's discovery explained the previously unresolved issue of atomic mass, as neutrons, along with protons, contribute to the mass of the nucleus. The presence of neutrons also helped explain the stability of the nucleus, as they help to mitigate the repulsive forces between the positively charged protons. The current model of the atom, known as the quantum mechanical model, builds on these earlier discoveries but incorporates the principles of quantum mechanics to provide a more accurate and detailed understanding of atomic structure. In this model, electrons do not orbit the nucleus in fixed paths, as Rutherford had suggested. Instead, electrons are described as existing in clouds or orbitals around the nucleus, where they have a probability of being found. These orbitals have different shapes and energy levels, and the behavior of electrons within them is governed by complex mathematical equations. The quantum mechanical model also recognizes that protons and neutrons in the nucleus are made up of even smaller particles called quarks, held together by the strong nuclear force. This model provides a comprehensive understanding of atomic behavior, including the interactions that govern chemical bonding and the properties of elements. In summary, the development of the atomic model began with the philosophical ideas of Democritus and evolved through the scientific contributions of John Dalton, J.J. Thomson, Ernest Rutherford, and James Chadwick. Each scientist built upon the work of their predecessors, leading to the sophisticated quantum mechanical model we use today. This model continues to be a fundamental aspect of our understanding of matter and the nature of the universe.